So welcome everybody to the VRBB panel today. What does VRBB stand for? VRBB is the Virtual Reality Berlin-Brandenburg e.V., eingetragener Verein, in English, a non-profit organization to boost the VR and AR businesses in the region by bringing together people like you, potential clients, AR/VR players, and create a network that is good for the businesses. The VRBB has been founded in springtime this year. We have had 25 funding members. At the moment, we have 40 members. And I want to do and push this a little bit forward and make promotion for the association for you to join. Please consider this. And you can get more information at the www.virtualrealitybb.org or just send us an email. Today we have 4 members giving a short presentation of 10 minutes, followed by our special guest Monika, and when hopefully we will have 10 to 50 minutes left for a Q&A session and open discussion with all of you here. So for our first speaker, he will tell us how augmented reality models can be streamed to multiple devices without an internet connection or the need to download it. The session title is AR Offline Streaming with shoutr.Boxx. Please welcome Ronald Liebermann from shoutr Labs.
Hello, everybody. Nice to be here. I'm here from the Berlin-based startup shoutr Labs. We are a spin-off from the Humboldt University. And at first, I want to introduce our team. These are the 4 founders. We have here Sebastian Winkler, Benjamin Werner, Christian Bayer, and me. We at first developed the shoutr app. The shoutr app was very special because the shoutr app was able to send data or to connect different devices and to send data from one device to another without the use of internet. And that means our technology or our idea is to provide data, big amount of data, without internet, without servers, and without infrastructure. To provide these, we have invented the shoutr.Boxx. The shoutr.Boxx itself works similar like a small server. So there's a computer inside, there's a Wi-Fi module inside, and there's a hard disk inside. Mainly our customers are museums. And the idea behind our service is how can we provide data to a lot of people at places where you have a bad or no internet connection. And when you use augmented reality, there's always the same question. How can you provide augmented reality data? To see augmented reality, there are 2 possibilities. The first one is you download the 3D content on your device. Then it needs, of course, space on your device. The second possibility is to have the data streamed from the internet. Our shoutr.Boxx only needs power. And it opens a Wi-Fi, a local Wi-Fi. You can connect with your device to the shoutr.Boxx and then stream the augmented reality data from the box to your device. And these boxes are also smart. So they are able to communicate with each other also per Wi-Fi. That means they can enable a big mesh network. And one use case, as I said, we implement these systems in museums, for example, the Museum for Natural History in Berlin or the Salvador Dali Museum, for example. These boxes are just implemented in the museum. They only need power. And with a CMS, the workers in the museum can upload all the content by themselves. And of course, not only augmented reality. It's videos, audio files, text, pictures. They are all saved in HTML5, like web apps. And you go through the museum, connect with your device to the system, and the content comes directly to your device. It's cached, so it doesn't need any space on your device. You don't need an internet connection for it or your volume. Our system also has more features. For example, we also work with beacons. That means we have also indoor localization. So we can have statistics. How do the people who are in a museum or in a showroom behave? Where do they go? What are the most interesting informations for them? We can also have heat maps. we can also provide internet with the boxes. That means one box, we call it the mother box, it has an internet link. And this box provides internet to all the other boxes in the system. The good thing on it is that the high volume data, like the HD videos or the augmented reality, 3D, virtual reality data, is on the box. So this is not streamed from the internet. It's local, so that is very fast. And if the users want to go to the internet, they can. But the most data that is used is local and provided. A few of our customers, we work together. Of course, I said the Museum for Natural History in Berlin. The touring exhibition Tutankhamun also used our technology. And for temporary or moving installation, this is a very good technology because it's easy implemented into the furniture of the exhibition. It only needs power, so it's easy installed, and you don't need internet or Wi-Fi at the location where you have the exhibition displayed. The exhibition in the university in Leipzig, Universal Library, also uses our system, and we also work together for over 1 year with the German War Memorial Association. We have implemented our system at 2 war cemeteries in Belgium to the First World War. Here we use our system in a different way. The data is saved on the box. The people who go there are able to connect to our system, download the content, and then walk over the war cemetery and view all the content that's triggered by GPS. In other cases, we use beacons for the localization, and we are now planning the first museum that's only with augmented reality. So there will no beacon detection, there will no numbers you have to enter. You just go through the museum and your camera detects the objects and then displays information. Some examples of what we have done so far. Our first big installation was this year at the CeBIT fair in Hanover. Here at the CeBIT Global Conference, and we displayed in cooperation with the Museum für Naturkunde, first time the T-Rex in 1:1 size. Yeah, again, dinosaurs today. And we also did that at the Museum for Naturkunde. This is the Museum for Natural History. You see how Tristan, that's how the dinosaur is called, enters the museum. And there was one event, it's called Lange nach dem Museum. That means one night all the museums have open. And there were several thousand people in the museum, and they all made pictures with the dinosaur and posted them on Facebook, Twitter, and Instagram. Here you can see how Tristan is walking through the museum and looks at the skeletons. The next case, this is a video. Play. Okay. This is also a little bit older video. This is a video where we display at the construction site the building, how it should look in when it's ready. Also here we can use the shoutr.Boxx in an outdoor version. We have our prototype that works with solar power, so you can install our system like everywhere. I always say, like fun, our system works on the moon. It only needs the sun, then you have the Wi-Fi there, all the information is there, and it gets streamed. So you can display, for example, in a construction site, a big amount of data, the whole 3D arts, the pictures or virtual reality information about how the building is going to look like when it's finished. And people who can walk by, or also people who are interested in, can now connect to the box and see the 3D data. Next video. Yeah, this is also an interesting video. This is also works in the same. This is one case we make for a showroom. You can save also, as you see here, 3D data that you can also change on our plug-and-play system and implement it, for example, in a showroom for cars. And people who are interested in can go in, can connect to the system and have access to all the 3D information that is saved on the box. And you can also, as I said, connect it with the internet, so you can also go directly to the shop and get more information or buy the car, as you know. And also not only for car showrooms, also for example in supermarkets. It's often no need to provide internet to the people, but of course the customers are interested in product information, and all the product information, as I said, is saved on the system. It's very easy installed, and then the customers are able to connect to the system, get the information without the need that you have to provide a big and fast internet at the place. Yeah, that's it so far. If you have any questions, we have our stand downstairs. You can connect to the box there and test the system for yourself if you want, and we look forward to see you. Thank you.
So as I said before, please hold back your questions for the moment. We will have an extensive Q&A session at the end of all presentations. Our next speaker will tell us how real people can be filmed in a way to bring them into VR so that people can walk around them with all the benefits and pitfalls. The session title is Walkable Films in VR, or How Do I Bring Real 3D People to VR? Please welcome Nico Nonne from Trotzkind.
Thanks. I actually really like the dinosaurs. I wish we were doing the dinosaurs and doing photorealistic, one of those. Actually, that photo is from 1.5 years ago, and we wanted to make the point of how do we get photorealism into VR, or AR for that matter, but we first focus on VR. And while I wish we could doing the dinosaurs and really could do them photorealistically, actually we're focusing on people. And really try to find out how can we use storytelling in VR, and what do we need to do in order to bring photorealistic and realistic looking people into VR. And when we look back on the history, there was around 1800 there were photos, the first step behind painting and telling stories just verbally. And then we had the opportunity and the ability to capture things photorealistically. And then on the next step, we made films like 100 years ago. And then all of a sudden we had photos, in a sequence, and we couldn't make it and film it. And now we're just borderlining on the step of going into real 3D. Not what you see in the cinemas, like stereoscopic, but moving around and having the whole thing in the space. And so the thing is, at the moment, we watch films, and it looks like this. And we go and see Game of Thrones, and we see the actor come up. We see all the details on the face, and it's all real, and we really feel it. All the emotions are there. And then we play the same thing as a game, and then we see this. Don't get me wrong, the game is still great. But just from the visuals and doing something in real time, it's still far off. And we don't get to see the same actor, the same person in VR that we saw before. So we're thinking, how can we actually solve that problem? And at the moment, this is what we do, right? Motion capturing for games, usually, or even for big-budget Hollywood movies. Capturing then in mocap, moving around. And at the same time, we have traditional film. And we just capture them from one side. And now we do it in 360. So we have one point of the camera, and we look in different directions. We can look around, but we can't move. So the whole thing you see downstairs with the HoloLens, with the Vive, with the Oculus, it doesn't work because you can't move. But that's, of course, not that great if you want to tell a story and have that room, that space that we finally got. So, of course, we experimented. We as Trotzkind, we experimented around and did different things. So we started with doing something that's 360 but interactive. We did a little bit of Tatort story. That's very German, and it's like a crime story. So it's actually Watson, more like Sherlock Holmes and Watson. And you got to decide at some points, what do I want to do? Do I want to go after this clue or this one? And it was a short story, and you could play it, and you had those decisions. But basically, the idea behind it was more or less like full motion video did a couple of decades ago. You inserted the DVD, you got those choices, I want to do this or that. And then you got to the next point, and the story was playing. And of course, we can fool people into thinking they get a lot of choices, the way we do now with games. Basically, games is still one big story tree branching out. And if you do it really well, they don't really see that there are so many branches. And so this is basically what we're trying to do there, but It's okay, but it's not perfect. 360 video just has too many limits, like not being able to walk around and standing next to a person like you want to. Then we combined this a little bit, and we said, you know, there's something else. It's called RGBD data, that you're capturing basically the depth, so the distance between something, and the color image, like a film. And we put this together, and we made it a little bit like gravity. So in gravity, everything is fake, right? Everything is CGI except for the spaces. These things that you can't really perfectly replicate at the moment, because there are just too many little details in the face which you need to capture perfectly, which we can't do really well. I mean, we're now doing it borderline, right? On Hollywood, in Hollywood, there are some systems that do it very well, but doing this in real time is still not working. And here, we did something to have an actress. We had her as an astronaut. We combined it with CGI, and it was interactive. So you could do a lot of different things in there. You could fly around a little bit and land on Mars, and we had our own story in there. But of course, it doesn't stop there. We still want to get to the point where you can move around. And so we do a technology cooperation with the Fraunhofer Institute. They are a big research institution. And we're developing a technology in order to film people really three-dimensionally. So now, for the first time, you can really go and capture people in a studio in a way that you can move around them. And all of a sudden, you get a lot of possibilities what you can use it for. And of course, on the entertainment front, I think we'll see films come up. Films that really play in the space, where you have to look around, go next to one. And of course, there are stars. All the people that we just see from television, it's completely different if you see them even in 360 compared to standing next to them and being able to move around them. You know, and be it some big music star, some Hollywood actor, or maybe a politician. There's so many different things and ways where you want to be connected to someone else. And that's the difference. Immersion, presence, what everyone is talking about, it's a lot about having a connection to the world. And if the world is empty, that usually doesn't work. So what we try to do technology-wise is we take a lot of cameras, like usual video cameras, just good ones, and we place them around the person. And then we record all of that, and then we use a lot of algorithms and data to get those together into 3D. So it's not like in the cinema at the moment where you just have one point of view where you look at the screen, but you really can move around all around the person. And you know, if we do this, then maybe at some point we can really do the hardest way of animation, getting the faces right, getting everything right, because we're just capturing that from actors. So then we can finally do this scene in VR. And we can finally get in there and have all the facial expressions there, and this is something that all animators, I think, want to do at one point. But to capture that, we could use actors, and now we can use them in VR and really get into that space. And that's what we have been trying to do, and this is the technology road where we go to. And if you want to, we can actually try it out, because we've got our demo downstairs at our booth at Trotzkind. And very German name. I know everyone who's not a native German speaker probably has problems with that one. But you can try it out. And we have an HTC Vive there. You can walk around the space. And I could show a video here of it, but the truth is no one really gets it in a video. You always have to try it with VR, with movement, and with being able to experience it yourself. And then, of course, we added some elements in order to make it interactive. So finally, you can pick up stuff, do something, and combine that linear video version of 3D people with interactivity, gameplay, and something else. Yeah, try it out. That would be cool. Thanks.
Thank you. Storytelling in VR is different from conventional storytelling. Our next speaker has gathered a lot of experience about the do's and don'ts, especially in the field of 3D animated VR content. The session is about 5 things you always wanted to know about animation and virtual reality. Please welcome Fabian Quosdorf from Wonderlamp.
Hi. So hello, everybody. Thanks a lot, Nico. I can actually agree to Nico. It's really, really nice to see this holo-scanned characters in VR. So I can encourage everyone to try it out at their booth. We are actually a small startup company from Potsdam. We are based in the famous studio Babelsberg. Does it work? No. Ah, okay, that's the one. Yes, there it is. Okay. So Wonderlamp Industries was founded by filmmakers, actually, and by people who try to bring new technology to everyone else. So the vision of Wonderlamp Industries is actually to tell compelling visual stories and to make the art of animation available to anyone without the need for actors, for real actors, for special skills or high budgets. Because nowadays, if you want to create a story in VR, let's say a 360-degree video, everyone can actually go out there and buy, let's say, for example, a Samsung Gear camera for only $300, and then you can actually start creating movies in 360 degrees and in VR. But this is not possible yet in 3D animation. So producing professional videos in 3D animation is still very, very expensive. And what our final vision is to actually create a story for VR in VR and to enable everyone out there to make it even with their own smartphones. During our development of the software we are creating to do this, we of course produced our own web series. So we are currently in the production of a VR web series called Brothers, together with EVA-Film from Munich, which we will bring to the audiences, I think in this autumn, to YouTube and Facebook, and of course to the Gear VR. During our production of this movie, we came across a lot of difficulties, which I would like to talk about shortly. So first of all, what we found out is it's really difficult to get the terminology right. So first of all, there's of course the non-interactive stuff, like the 360-degree videos and the roller coaster rides, how I like to call them. So even, yes, in those experiences, the camera is fixed on a solid point and the user can actually look around in a circle and see everything like in a dome experience and watch the show. What the user cannot do is he cannot interact with the scenery actually, other than looking around, and the scene does not react on the user. So when producing such a video or an animated show, you have to take this into account, of course. And now I would like to show you a short video. I tried to record this, of course, in YouTube, because YouTube is capable of actually simulating this looking around. So here we are in a virtual record store with two guys just telling a story and talking to each other. And the user, while watching it, he can actually look around everywhere and try to get a feeling of the scene he's actually in. What works really good, actually, we found out, is that you can do camera cuts. We also tried to actually focus the user's attention to specific points in the scene. For example, the steaming coffee machine or the fridge, which starts to go on and off. And of course, the sign in the back, to actually make it more interesting for the user to watch the story over and over again and to find out new stuff that's happening around him. Yes. So then there's, of course, the real VR, so the interactive version. This is an image of the Emmy Award-winning Henry by Oculus Story Studio. In this case, of course, everyone who used a Oculus Rift or an HTC Vive knows what I mean. The user is actually the camera. He can walk around the scene, he can actually interact with the scene, look around and move. And of course, the actors in the scene are aware of the user who's standing right in front of them and can therefore interact with them. When creating stories for VR, you have to take this into account, of course, as well, to make the experience for the user as cool as possible. Our approach was to think stage-based and not shot-based. Here is a picture of a film set, of a traditional film set. And the problem you have with this is that the user has 360 degrees of freedom. So this means he sees everything. He sees the cameraman and the tracks and everything. You can still cheat in the distance and try to hide everyone out of the scene if you are on a real film set. What you definitely should do is make use of the whole scene by, for example, using some interesting stuff going on at the back of the user and try to guide the user's view to points of his interest. What we did to plan out the story, we laid out everything in a panoramic storyboard. So we actually put together the storyboarding phase and the blocking phase in the same process, actually, and took 360-degree screenshots of the whole scene that we already created in our software. And then we could actually plan ahead with traditional storyboarding, but we already knew what would happen at specific points in the scene. And this makes it very easy to actually plan out everything in a very fast and attractive way. The next thing that we learned is that you have to develop for this new medium. This means one thing that comes to your attention when you put on the goggles at first is that the scale feels different, especially if you're using non-stereoscopic movies. So you really have to pay attention to the scale. You need to review your animation in VR. If you do it on a flat screen, it just doesn't feel the same. Then the one thing that's very interesting is that real-world phobias can transform into the virtual reality. So my colleague, for example, she's afraid of the deep water. So she can watch a movie of divers in the deep water on a flat screen. But as soon as we put her into a virtual ocean, where, let's say, just some beautiful fishes are passing by, she totally freaked out at that moment because she was totally immersed in the scene. And this is something you really need to take into account when producing stuff. Nausea, of course, is a big issue. High frame rate can actually help. And the one thing we learned is try to think stereo, not mono. So in 3D animation, it's very easy to create stereoscopic 360-degree videos. So if you do that, please do it. So don't do the monoscopic things. And give the users time to adjust, because in the end, it's a new medium, and they need to adapt to it. So plan your camera tracks or puke. You have to do different things than you would normally do in a traditional way of filming. You cannot use specific focus points, and you cannot use depth of field as you would in a traditional way to put a focus on specific things in a specific depth of the scene. You shouldn't do fast movement. Try to prevent it at all costs. Very slow movement is always good. Camera cuts, again, are fine, as long as you do not do hefty directional changes. And the motion must be plausible. So let's say if you move in very strange directions while your body is situated in a chair, then it sometimes feels very strange for the people if they go up and down or left and right or just turn in circles. And please don't use the vertigo effect. This will kill everyone. And here is why. Although this is really funny from the outside, I think the poor guy wasn't having the fun of his time. He was actually only running a roller coaster. And as soon as he was touched from the back and everything started, he was actually standing, but his body told him, or his brain told him, that he would be sitting in a roller coaster, and he couldn't get this together. And I think this will happen to a lot of people. Yeah, just in short, sound is also important. So try to create 360-degree audio. YouTube and Facebook can actually play this back. Okay, thank you very much. Visit us at the startup area. I would like to give you a demo of our storytelling app if you want to. Thanks.